So today we'll be talking about the American Industrial Hygiene or AIHA strategy for assessing exposures. This is one of the most commonly used and cited strategies around, and it is also very similar to other strategies in that it shares similar features and it has a similar goal, which is the industrial hygiene imperative, which is to know and control all exposures and also aid in decision making. We'll start off today with looking at the flow diagram for the exposure assessment strategy. The first thing we'll be doing is focusing on the first rectangle in the top, which is basic characterization. But before we get to that, let's just talk about this flow diagram in summary, and then we'll look at each element. So we start off with the oval at the top, which says start, because it's very important to actually have a strategy and write it down, and as an institution or company follow that strategy rigorously every time. So that's why this oval says start. Then we follow with a basic characterization of the workplace and the chemical and physical agents that we want to characterize, the types of work that are being conducted there, and the different types of workers that are in this workplace. Following which, we actually carry out the exposure assessment in the diamond. And the result of this exposure assessment, which is an assessment of the 95th percentile of the exposure profile that we have discussed in previous lectures, we compare that 95th percentile with an exposure limit and arrive at a decision that the exposure is either acceptable, unacceptable, or uncertain, meaning we still don't know enough to make a valid comparison. If it's an acceptable exposure, then it's great, and we come back to this particular group of workers after some time and do a reassessment. If it's unacceptable, then we need to implement some control measures. And if it's uncertain, that basically means we have to gather more information so that we can actually make this comparison. And as you can see, it's an iterative process. The arrows go back, and you are continually evaluating all the workers in this workplace. So let's begin at the first oval, the start. The start is to actually establish an exposure assessment strategy. And it seems like a trivial and almost funny thing to say, but most organizations do not have an exposure assessment strategy. And they just sort of make ad hoc measurements and compare against an exposure limit. And they don't really have a plan about what to do with those measurements. So it's very important to set your goals for exposure assessment. What are the decision metrics? Write them down. And also in this process, understand the role of the industrial hygienist. The industrial hygienist who is implementing the exposure assessment strategy has oversight and direction for this entire decision-making process. He or she brings to bear their professional judgment that is very important for identifying similar exposure groups, or SEGs as you know them. And this professional judgment is essential for judging exposures in many scenarios. And finally, the industrial hygienist also defines and prioritizes the follow-up for the monitoring and control programs. Following that, we come to the first major part of the exposure assessment strategy, which is the basic characterization of the workplace. The goals of this step are to collect and organize all the information on the workplace, the workforce, and the work agents, meaning, the chemical and physical and biological agents that might be in the workplace. And the tools that are used for this step could be reference documents, previous records that the company or the organization has maintained. There are exposure limits and standards, standard procedures for carrying out various industrial tasks. You might also, as an industrial hygienist, talk to the workers who are engaged in various processes and tasks. You can talk to the supervisors or the plant engineers. And finally, you can also do a walk around, meaning you walk around the entire workplace and visually observe each process and make judgments regarding whether they should be higher up or lower up in the priority for exposure assessment and monitoring. And the outcome of this basic characterization step is a summary of what the workers are doing and how the workers can be grouped, the tasks that the workers are engaged in, the chemical, physical, and biological agents, and then also finally the health effects that might result from exposures to these agents. So let's dig in a little bit deeper into each one of these categories. So, in terms of the workplace information, this includes information regarding the industrial process that is occurring there and the equipment that is being used in this, the various controls, meaning exposure controls or means for controlling workers' exposures, and also the various materials that are being used in this. And in most modern factories and workplaces, we are producing very complex products. And you might have not just one chemical substance, but many 15 to 20 or maybe even more chemical compounds, for example, that go into making one product. And so we need to understand all of these features of the workplace. The next bullet is the workforce. So we need to understand the workers, and we do that by looking at their job titles for one. And in some cases, the job titles are very informative. For example, in a mining operation, somebody might have a job title called crusher operator, and it's very descriptive. And his or her job is basically to run machinery that crushes the ore into smaller and smaller pieces. But in other cases, the job title might actually not be very informative. So if you're working in a R&D lab, your title just might be senior scientist or junior scientist, in which case it is completely useless as a means of describing what you do. And so there you really need to dig in further and get into job functions and the tasks that they're doing. So two people with the same title, junior scientist, might be engaged in very, very different tasks with different chemicals and being exposed to completely different things. The third bullet is the agent. So we really need to know what are the chemical, physical, and biological stressors that are in the workplace, what their health effects are, what their occupational exposure limits or OELs are. And if they have them, sometimes there may be no OEL if it's a brand new chemical, for example. And also, are there any exposure monitoring results available for these agents? As an industrial hygienist, we really need to understand the flow of the process and material in the workplace. We need to understand the chemical and physical processes that are occurring and where the different process streams end at and what are the waste streams, and be able to identify potential emission locations and where the controls are. We need to be able to locate the tasks that require the handling of materials. How are the work practices affecting their potential exposure to these hazards? And are they using any personal protective equipment or PPE? And are there any other kinds of engineering and administrative controls in place? Next, we come to workplace factors. So we look at the building type. So if it's a closed building, or is it an open environment where, again, using the mining example, or the doors and windows are mostly open and crushing is occurring there is a building structure, but it's really, there are doors and windows that are wide open. Or if it's a fairly closed building, meaning that you can expect higher levels of dust buildup. What are the chemical and physical processes that are occurring there? Because such processes affect the type of exposures that might happen. And I'll give you an example in one of the following slides. What are the energy inputs? Are we, for example, putting in energy in the form of crushing this ore, or are we smelting it where it's a chemical process that is heating up the ore to a very high temperature as opposed to physically crushing them? And so these two types of energy inputs lead to very different types of sizes of particles that might be generated. What are the types of equipment that are being used? And what is the kind of ventilation in the workplace. So if you have a building that is wide open and you are relying on natural ventilation, that's going to lead to one kind of exposure, as opposed to if you have forced air ventilation and local exhaust ventilation in a lab setting, those lead to very different types of exposures, and the level of control is very different. Before we start doing anything regarding exposure assessment, we really need to understand what is happening in the building. Do we have a map of the entire building? Do we understand how the material is flowing through the building? And where are the ventilation systems located? And what is the chemistry? Again, going back to that chemistry, is there an understanding of the chemical processes in various locations in the building? And do we have standard operating procedures? And then finally, like I said earlier, we can get further information that may not be written down from the interviews with workers and engineers and chemists and so on. So this diagram is a flow chart of how the materials flow through a particular mine. This illustrates some of the things I talked about in the previous slides. So this is a nickel and copper mining operation up in Canada. So the ore comes from these mines and they're transported by these big trucks to the mining and milling operations. So the first step is the crushing and screening of these large rocks, essentially containing the nickel ore. So at this point, as you can imagine, when you are crushing rocks, you are going to generate a lot of dust. And so the workers in that particular part of the plant would be exposed to a lot of dust particles, which are large particles in size. And then you go into the grinding process. So here you're going to generate more fine dust. It's still a dusty operation. And then you add various reagents to it. Now we get into this area where you do what is called froth flotation, where you are mixing this powdered ore with liquids, and the metal bearing particles rise to the top of the liquid, and the waste or slag settles to the bottom in some cases. Or it could be the reverse, where the metal settles to the bottom and the waste rises up to the top. In either case, the two parts are separated from each other. The waste slag, as it's called, and the metal bearing, they are separated physically. And since it's a liquid operation, again, just using common sense, we might say, okay, the exposures to dust are probably going to be less here. At this point, now we take the concentrated particles of the nickel or copper ore, and it goes through these concentrating processes where you're removing the water by essentially heating up the slag or the metal bearing more concentrated ore. And at this point, you are transporting it to a smelter process. So as you can see, the different physical and chemical processes here can give you a sense of how you might want to classify workers later on. So here, this is a more detailed picture of the crushing part of the ore, and it is a cone crusher, and it essentially is no different than a coffee seed grinder, except it's at a much, much larger scale. The ore-bearing rock is poured from the top, and you can see there's a conical middle part, and there's another metal part that sort of crushes the ore in between them. And what comes out of the bottom are smaller particles. So this is a very dusty area, as you can expect, and the energy is being input in a mechanical form. And on the right is an example of that as an actual photograph of the cone crusher, and you can see these big piles of crushed rock in the background of these two guys over there. So here on the right is what is called a converter, but here the energy is being input in the form of high temperature combustion. And so it's the same ore now, but you're now going to heat it up to a very, very high temperature, and you're essentially melting the ore as well as the metal in it. And you can see a photograph again of this, and you can see the metal fumes coming out of this operation. So these are much finer particles being generated here than in the dust and the crusher operation above. So by knowing the form of energy that you are supplying, whether it's just mechanical crushing or chemical combustion, you can predict the type of exposures that the workers here might have. Now we come to understanding the workforce. So we here need to understand the division of labor and work practices, and we need to consider the exposure pattern. What is the pattern of the jobs and tasks that are occurring? Are the jobs and tasks routine or versus non-routine? And I'll talk about this more later. The exposure frequency, the use of personal protective equipment, potential for skin contact, and so on. Here we may want to use plant rosters and organizational charts and a description of the job. And an important thing to note here is that a job description may not be unique enough, as I talked about earlier in the example of a lab scientist versus a crusher operator. And we get a lot of information typically from interviews with workers as well as supervisors and management. And very frequently, if you're an industrial hygienist, you may actually want to go and observe the workers to get a better understanding of the work, what they are actually doing. And some of the features that may be very important from an exposure perspective may not really register on the supervisor or the worker themselves. When we come to the environmental agent, we need to be able to identify all the physical, chemical, and biological agents that the workers might be exposed to, their potential health effects, exposure routes, the occupational exposure limits, and their physical properties. And it's very often the case that industrial hygienists identify what they consider are the most important chemical agents. And while that is useful, what is really recommended is that we identify all of the agents that are in the workplace and their exposure levels and exposure limits for those things. It's not enough to just use the industrial hygienist's professional judgment about what is the most important exposure, because the importance might change over time, and something that was considered relatively benign may prove to have health effects later on. So it's important that we identify all the chemical agents that are available in the workplace. For each of the agents that are in the workplace, we want to make sure that we know what the exposure limits are. What are the occupational exposure limits that might derive from regulatory agencies, governmental agencies such as OSHA? They may be set by organizations such as NIOSH or ACGIH or AIHA. Sometimes there may be internal OEL set by the company themselves if they are developing a new chemical, and they may have done some internal research to set provisional exposure limit. Or it may be set by the industrial hygienists themselves as a working occupational exposure limit.